Yeah, yeah. Let's continue here. Here we have tried questions. Who can
Teacher,
answer this? Yes, yes, Nasser.
teacher. Try question, for example, 3. What we write?
On average, okay. You can say on average, adults can do or exercise nearly twice as much as adults. On average,
Oh, on average,
adults
adults are teenagers.
or teenagers, sorry, teenagers, 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 um, exercise uh, nearly twice as much as adults. Okay, okay.
Yes, teacher, thank you.
You're welcome. Now let's move to practice and problem. And our here we have a key concept. You can use the clause to make and form a comparative inferences about two populations. You can compare the shapes. You can compare using the mean. You can compare using the mean absolute deviation. You can use these measures here as we have here that two data sets. Look here, we have two modes, 18 and 19, and here we have two modes, 15 and 16. So the modes is 15 and 16. Mode is a measure of center tendency. Okay, it gives you a center of the data, and the range is 10 here. You can calculate it by subtracting the maximum minus minimum, and here 25 minus 14. The range is a measure of dispersion. Okay, so the modes of the data set are greater than the modes of data set A. The mean of set B is greater than the mean of data set. You can infer that the data points are generally greater than data set B. So here data set B is greater than data set A, and this is the inferences that you can make from studying the mean and studying the modes. And here the ranges and the mean absolute deviations of data sets are similar. The range is 11 here, it's about 10 here. You can infer that the variabilities of the two data sets are about the same. Okay, now let's go here. Yeah, Abdullah, question number 6, please.
A study is done to compare fuel efficiency of cars. Cars in Group 1 generally get 23 miles per gallon. Cars in Group 2 generally get for about 44 miles per gallon. Compare the groups by their means, then make an inference and give the reason for the inference might be true.
Excellent. Yeah. What do you think
Teacher,
here?
from where I get the mean?
The mean fuel efficiency 23 miles per gallon for the first group and 44 miles per gallon for the second group.
They're the mean?
Yeah, yeah.
Okay, the mean for Group 1 is less than the mean for Group 2.
The mean for group 1, excellent. Yeah, the mean for group 1 is less than the mean for group 2. Now, the cars in a group, here we have another inference that we can make.
Group
The
2.
cars in a group generally more fuel efficient. Group 2, excellent. Yes, and what about the cars in a group? Maybe smaller, or what do you think?
Group 2.
The cars in yes is small, maybe smaller. Yeah. So depending on the means that we have from studying group 1 and group 2,
Teacher,
we can make two inferences. Yeah.
why fast when we say group 2? The cars in group 2 may be smaller.
Smaller in the size.
Yes, smaller because because of the fuel efficiency is for 44 miles per hour per gallon. Sorry.
Oh, okay.
Okay. Now, what about question number 7?
Abdullah.
Nasser.
Nasser, yes, it's your turn. Thank you, Abdullah. Yeah.
The dot plot shows a random sample of vertical leap heights of basketball players in two different basketball camps. Compare the mean value of the dot plot round to the nearest tenth.
Thank you. Why it's 303? You know why 303? This is the way we can calculate the mean. From where we got
Yes,
303?
we added all of the dots.
Yes. You added all the values here. 22 plus 23 plus 25 plus 25 plus 27, 27, 27 plus 28, and so on. So
Then
303
divide by the
divided by
sample
11
number.
by the number of data
33.
values.
No, wait.
Uh,
30.3. Yes, 30.3.
it's 27.5.
Oh, really?
Yeah, because you divide by 11, not by 10. Okay. Now, what about the second group or the second camp?
Mm.
If you add the values here, you will get to 6, 8. I have the answers with me. So also you have the answers. 26, 268 divided by 11, it gives you 24.4. Okay, and the mean values tell you that participant in camp, which camp?
1.
Camp 1. Excellent. Okay. Okay. What about question number 8?
Abdullah.
Yes, Abdullah. Thank you.
A researcher divides some marbles into two data sets. In data 1, the mean mass of the marbles are 13.6 grams. In data 2, the mean mass of the marbles is 14 grams. The MAD of both sets is 2. What can you infer about the two sets of marbles? That the median for the second data set it's larger than the first.
And data set 1 or yeah.
What does the MAD means? I forgot.
It gives you about the dispersion, an indication of dispersion. Let's say that we have this shape, okay, for the some group of data, and let's say that we have this shape for some group of data, and let's say that this is the mean, and this is the mean, okay. Here the MAD,
It's the difference between the variables and the median.
yes, or the mean, yeah. It gives you the distances from the values that you have to the mean. And here, okay, if I ask you,
Which value?
what do you expect about the MAD? Is it larger here or here? The first
Down.
or the second? Yes, it's larger down. Yes, yes, Abdullah.
It's
It's
in the
larger
second
down.
part.
Yes, because it gives you the distance between the
But
data values on average.
teacher,
The
the
average,
distance
average,
between which numbers?
the average distance, the average distance, the average
The teacher
distance.
between Q1 and Q3 and the mean.
No, from the values that we have. Like if you remember our yesterday, let's say our yesterday example was we have the values 2, 4, 4, and we calculated the MAD. The MAD, the maximum, the mean absolute deviation was 1. Okay, so if you graph, here we have 1, here we have 2, and here we have 3, and here we have 4. This is our mean. Okay, and this is
Teacher,
our mean.
between the two closest number for the mean.
No,
Yes.
on average, the distances. Look here. Here, the distances, we have 4 distances. We have 1, 1, 1, 1. If you add them and divide them by 4, it gives you 1. So the mean absolute deviation 1 means on average, the points here or the data values are far from the
But
mean
teacher,
by 1 unit.
but
Yeah.
from 1 to 3 it's 2.
From 1 to 3, I do not have 1 here. I do not have values on 1. From 2 to 3 because we have 2 values on 2,
Oh.
2 values on 4. Like if I told you you have
Oh,
this,
teacher, now I understand it now.
yeah,
It's the mean of the
like the mean of the distances.
the variables to the mean.
Yeah,
Okay,
the
it's the
data
average,
values.
right?
Yeah, the average distance.
Okay, now
Like
I understand it.
yeah, So let's say that you have these data values. Okay, let's say that we have here. Let's say also we have a data value here on the mean itself. Okay, we have a 3 here. We have here the distance here is 1 unit, and here the distance 1 unit. Here we have 2 units. Okay, here we have 0 units, and here we have 1. Let's say here we have 2. So add the values here, 1 plus 1 plus 2 plus 1 plus 2, and divide them by the data values that you have.
1.3 infinity.
The mean absolute deviation, it becomes here 2 plus 1 3 plus 2 5 6 7 7 divided by 1 2 3 4 5 7 divided by 5. So on average 7 divided by 5 1.4. So the average distance between each data value from the mean is 1.4. Okay, it's more than 1 here. So we can say if you graph the, let's say, the shape here and the shape here, the dispersion here is more. The
So
dispersion.
it's the average of the distance from the variables to the mean.
Yeah, to the mean or
Not
the
the numbers.
median. Yeah. The average of the distances, because in general, look here. If you have xi minus x bar, the mean, and you take absolute value and you divide by the number of data values that you have, it is the same way as you calculating the average. The average distances, the average of the distances between the data values and the measure that you choose. Here we choose the mean. Sometimes you can choose the median. Okay, sometimes the mode, as you like. But if you have outliers, the better measure is to use the median. Okay, this line. So the mean absolute deviation. The mean. I'll just share it again. In general, you can use this rule 1 over n. Here it's written like that. If you look at uh, the box, it is written like that. X. Okay, m of x means you can use x bar. You can use this means the mean, and you can use the median. You can use the mode from I equals 1 to n. Here for m of x, you can substitute the mean. You can substitute the median, any measure of central tendency, to calculate the mean absolute deviation. Okay, depending on the data values that you have. If you have outliers or extreme values, you can use the median. If you do not have extreme values, you can use the mean. Okay, so this is about the this lesson, and you have some questions. I put for you a questions from Savas Realize, easy questions you can do. We have some questions here. Look, we do not have time. Look, yeah.
I can't see your screen. It's black for me.
No, I see it, teacher. I see it.
No problem. I appreciate it. Look here. You have some questions. Like here, we have a question. Who can answer this question?
Abdullah.
You can look. Yeah.
No, thank you, teacher.
You're welcome. Yeah. What you can say about the medians?
That the median of Rob's data is greater. A.
Yeah, it's easy.
Teacher, this will come in the exam.
Yeah, of course. Similar to this question. Okay.
Thank you.
You're welcome.
No,
Abdullah.
Yes, Nasser. The next question you can, if you can. Yeah.
Wait, teacher. I can't see it.
T1 and
yes, now. Yes. Yes, now. The following box shows the different heights of two types of trees. Which best describe the of the following for the blocks plots? Use pencil on paper. Yes. The medians. Good job, really. Yes, they are the same, I think.
Yeah.
Correct.
Yeah.
The interquartile is different, I think.
Yes.
Or may no. The same
No,
even. Not
the same.
the same even.
The interquartile ranges are the same because the difference between Q3 and Q1 is the same. And here, who can
Abdullah.
answer this? Yeah, Abdullah.
A family is looking for a new home. The family comparing homes in two towns. The median home of price in town one it's $25,000. In town two, the median home price is $176,344 based on the median of the home prices of each town. What inference may can be made? What else might a person conclude from the median values?
See.
A.
Yes, excellent. Because the price here is more. And what is the other info? Which of the another conclusion? Yeah. Yeah.
Oh. Town one are probably greater in size.
Excellent. Yeah. Because of the price also.
Yes.
So as you can see, the questions are very easy. Nasser, you will answer some question from 6-4. Let's see questions. Yeah, 6-4.
This was 6-3. Oh.
Yeah, this is 6-4. It's the same. Making comparative using samples.
It's downloading until
Yeah.
now.
Yeah.
Yes. Which of the following? Okay. A study is done to this is like the one in the book. The first group of cars generate about 30 miles per gallon. The second group, it's B.
B.
No, wait. No, A, I mean.
A.
I thought B means
They are
equal.
equal.
I thought B means
And
equal.
here,
Yes.
which of the following is
Really, it's freezed when you put nice work. I don't
this
think
is the correct?
we have
This
time.
is this is the always the correct answer. Which of the following is another conclusion that a person might make from the mean values? The cars same size, I think.
Yes.
Okay, as you can see, the questions are very easy. Okay,
Right.
so our period is finished now. Thank you for all of you. This
Goodbye,
video lecture
teachers.
is already recorded. Bye. See you.
Goodbye.
Okay,
See you
thank
on
you.
Sunday. Have a nice weekend.